Okay, hi everybody. This is the Math 31 integration review. This is question 3. We're going to answer this question by using kind of an interesting substitution, and it's going to be suggested to you in the problem here that x is going to equal sine of theta. So if that's the case, then we're going to get the square root of 1 minus the sine squared of theta over the sine squared of theta dx. Now we still want to get we got to get rid of that differential here, change it to a d theta. So we're going to use the fact that x equals the sine of theta. So dx by d theta will equal the cosine of theta. So the differential dx is going to equal to cosine of theta d theta. Okay? Now I can plug that into here, make this the cosine of theta d theta. Now this expression is going to equal, now just think about this, 1 minus the sine squared of theta is cosine squared of theta. Square rooted is the cosine of theta, times the cosine of theta is right back to the cosine squared of theta, all over the sine squared of theta, d theta. And this will be the integral of the cotangent squared of theta, d theta. Now, off the top of my head, don't know what that is. But we can make an identity substitution. That's what's given to us in the problem here, in the question. We know that that's going to equal the cosecant squared of theta minus 1 d theta. That's what cotangent squared is. And in this is a little bit easier because I do know what the antiderivative of cosecant is, because I know that the derivative of cotangent is going to be cosecant squared. Okay? Sorry, is that... Calling, all of a sudden I'm having a brain fart. Is that right? Yeah, that's right. Oh, gee, that's kind of weird. So this is going to end up being negative cotangent of theta, and then minus theta, with a big plus c at the end here for the arbitrary constant. Now, the thing is, though, the question isn't in terms of theta, it's in terms of x. So we've got to go back to this relationship that we were given, and notice that theta is going to equal the inverse sine of x. So this is actually going to equal the negative cotangent of the inverse sine of x, close bracket, minus the inverse sine of x plus c. That's a really awkward looking result, but there you go.